Hello everybody. So we move on to the next module of Kerala Technological University. The fifth module is velocity kinematics and manipulator dynamics. These are two separate topics. First we will look at velocity kinematics and then we will look at manipulator dynamics. So first we will start with velocity dynamics with that introduction of velocity dynamics. Let us look at the introduction of velocity kinematics. Why do we need to do velocity kinematics? The first thing is that in the third module as well as in the fourth module, that is in the previous topics that we have discussed, we have decided on what should be the equation that represents the position and orientation of the end effector of any manipulator or robot. That means we have basically discussed in the third and the fourth module topics what should be the position as well as orientation of the end effector. Let me write that as a point. So in previous modules we discussed about how to position an end effector in 3D space. So we have only discussed about how to position it. But in this module, we have to discuss about the movement of that end effector. That means we need to also learn about how the end effector is moved, or we have to also learn at what speed the end effector is going to move, what is the equation representing that. So that's the next point. So we need to learn about the speed with which the end effector is moved. Now for that we have to also define an equation, and basically the equation that we define for velocity kinematics or the velocity of the end effector is through something that is called as a Jacobian matrix. So it is very important for us to write the Jacobian matrix for any robot for controlling the velocity of the end effector, and similarly we also need to plan the path in which the end effector has to move. For that also Jacobian matrix is helpful. So the next point is about Jacobian matrix. So for controlling the speed of the end effector, it is important to write the Jacobian matrix for the robot. Well, what is basically comprising of this Jacobian matrix? The Jacobian matrix basically connects the velocity of the end effector to the velocity of the joints. So Jacobian matrix is the link between what should be the velocity with which the end effector is moving and the speed at which the joint is moving. So it's a basic understanding, isn't it, that if we are having, let's say, a joint to which a link is attached or a tool is attached, if the tool has to move at a particular speed, it's the joint which has to move at a certain speed. It's the joint that will decide what is going to be the speed of the end effector. So basically Jacobian matrix mathematically connects between the velocity of the end effector and the velocity of the joint variable. So let me write that as a point. So the Jacobian matrix is a matrix that links the velocity of the end effector to the velocity of the joints. Now here people might be thinking, okay, what is the link between, or what is the relation between velocity of the end effector and the velocity of the joints? As I previously told, let me show it with an example. That suppose we are having a revolute joint. So I am having a revolute joint let me draw the revolute joint. Here is the revolute joint which is attached to a link and to the ground, and in the link we are having, let's say, a paintbrush, something, spray paint or some tool is there. Now what is going to be the velocity with which it is going to move is going to be actually dependent on what is going to be the velocity of this joint. So the velocity of the joint means the joint is moving at an angle of theta. Now when we are having the velocity, it means we are talking about how theta is changing with respect to time. And since it's an angular motion, we will call it as an angular velocity. Angular velocity. So let me write it properly. Angular velocity. And this angular velocity will decide at what speed this end effector is going to move. But you should always remember, when we are drawing an arc, this arc is small and this arc is large. So the time taken for both the arc is same. They both are totally two different distance, but they are at the same, they are drawn at the same time when you move from here to here. When you move from here to here. So it also depends on the link length. So the velocity of this that I can say is the velocity of the end effector is actually the velocity which is decided by the angular velocity as well as the link length. If you increase the length of this one, then the velocity will be more. So basically it is the velocity So we can write the next point as for finding out the velocity of the end effector, it is important to find the velocity of the joint variable. So unless and until we find out the angular velocity, we cannot find out the velocity of this end effector here. So let me write that as a point. So for finding the velocity of the end effector, it is important to find the velocity of the joint variable. So this is the basic introduction of velocity kinematics. We are basically interested in finding out the Jacobian matrix that relates the velocity of the end effector to the velocity of the joints. And this Jacobian matrix is important for defining what will be the speed of the end effector. We will get a matrix with which we will be able to always calculate what is going to be the speed of the velocity of the end effector, and this will be helpful for us in path planning. Next we will see how mathematically we can represent the velocities. Thank you.